Good morning, WVLK scientists. I am Malin.
And I am Parker, and we are coming to you live from our very own Weaver Lake Media Center, and today is Friday, December 7th, 2018.
There is one birthday today and 3 birthdays over the weekend. Now let's watch the screen and see who they are.
Hope you're going to have an amazing birthday, and don't forget to go to the office to pick up your birthday card so you can get that delicious cookie at lunch.
What's for lunch today, Parker?
Well, Malin, today's lunch is beef hot dog on a bun or macaroni and cheese.
That sounds amazing. Remember to say thank you to the lunchroom staff and don't forget to get your milk.
And now for the weather with Alistair.
Hello, fantastic students. I am Alistair here with the weather. The current temperature is 15 degrees. The high for Maple Grove today will get to 22 degrees. The low for tonight will be 9 degrees. Tomorrow the high will be 22 degrees. The low for tomorrow will be 18 degrees. It's a cold day today, and there's snow coming. Now back to our marvelous anchors.
Thanks, Alistair.
Now here's science in action. Let's watch this cool video.
Let's zoom into the wing of a blue morpho butterfly. We'll start with a digital camera, then move to an optical microscope, and finally, we'll see the wing under a high-powered scanning electron microscope. The blue morpho comes from the Amazon rainforest in South America. Its beautiful, blue, iridescent color is created by tiny nanostructures that interact with light in a special way. We can't see the nanostructures yet, but notice the rows upon rows of scales. These scales are made of a material called chitin. The true color of these scales is brown, but this brown material has formed millions of tiny structures that can manipulate light. An individual scale is slightly bigger than 1/10 of a millimeter. Now, as we zoom into an individual scale and transition to the scanning electron microscope, we start seeing the rows upon which these nanometer-sized structures live. Remember, a nanometer is a billionth of a meter, and that's really, really, really small. The nanostructures form short layers of chitin with air gaps between. Light can reflect or pass through the layers. The light then travels through a small air gap, then passes or reflects through the next layer, and so on and so on. As light hits these extraordinarily thin layers and passes through the gaps, blue light doubles up, while other wavelengths of light either continue passing through or are canceled out. The blue light we see is very intense. Scientists look to such examples in nature to inspire technological innovation. Now, on a blue morpho, the width of these layers and gaps don't change, so it cannot change its color. What if a scientist was able to make a material that could change the width of these gaps? Then we could see a lot of different colors.
Wow, that was an awesome video about nanotechnology.
The fun fact of the day is bananas glow under a black light.
Thank you for watching our news broadcast on the Weaver Lake News this morning.
Let's learn a lot and have an awesome learning day. Bye!